The next speaker has a long experience in software development, building sites with CMS platforms and also building CMS platforms. He's currently Chief Growth Officer at Exove. Got that? All right. At Exove, focusing on creating opportunities for growth. He's also an avid green coding evangelist and a researcher. He has published a book and lectures frequently about the topic in Finland and abroad. Please welcome our next speaker, Janne Kalliola.
Thank you. Thank you for the kind words that I actually wrote. So I'm here to talk about how to measure front-end energy consumption with Firefox Profiler. If I get my clicker working, yes. Okay, go away. I'll talk very briefly about me, the company, and the book. And then we go to why question, or why questions, and then how question, and then we have a measurement, and then demo. Let's see how that goes. And then some final words, and then you ask anything and I'll answer anything, kind of Q&A. So, as said, I'm the founder and the chief code officer of Exove. I started coding in '83 when I was 9 years old, so I'm 51 now, so the time goes. It's funny to see that the technical conference used to be so for young people, and now everybody has reading glasses here, myself included. So I don't know what is going to be in COBOL conferences. That is everybody with wheelchairs and stuff. So but that's where we're heading. And I've been working with green coding for a while, and I'll publish frequently about that stuff in LinkedIn. So if you are interested in it, then kindly do follow me in LinkedIn. Exove is a design company, software development company that we defrustrate the digital. So we make solutions that are easy to use. I have written a book in Finnish, Vihreä Koodi, and in English, Green Code, available for free. Just you need to give your email address, and there might be some commercial stuff coming from Exove to your way. Not that much. And then this is a bit old news that this was August 23 actually, so I need to maybe get my stuff together and start writing the third version. But the second edition was published with the AI, cryptos, IoT data, and plus other stuff. But let's get to the point. So why does the software energy consumption matter? I don't know if you know that the ICT sector accounts 4 to 10% of the world's energy consumption, and it emits 2.1 to 3.9% of the greenhouse emissions. These numbers are growing, and these are before the mass adoption of AI. So these are from 2020 or 21 or so. If you take the average of 2.1 and 3.9, it's squarely 3.0, and that number, when we take the global emissions, that is 58.2 gigatons from the UN emission gap report from 22, we get that we, as an industry, we spew 1.5 billion kilograms, 1.5 billion tons, not even kilograms, of carbon dioxide to the atmosphere every single year. To get a perspective, its big numbers are really abstract. So it's about the mass of all land mammals and people. And then when you think about land mammals, then you probably think about elephants and rhinos and so forth. But unfortunately, 2% of the wildlife, or 2% of the mammals are wildlife on the land, and 2% on the sea, and then rest is us and our cattle. So if you have ever considered being a vegetarian, now it's really good time to start, because this is really screwed up. So then, why software energy consumption is growing? What is the reason? Because I was on Wednesday listening to Jukka Manner, professor from Aalto University, that has been studying this for a while, and he had an interesting picture that there was the biggest supercomputer in the world from 2000 that was doing amazing stuff, scientific stuff. And then I borrowed this example here. I don't know whose phone this is, but this phone here has exactly the same amount of power than that supercomputer 25 years ago. And what we are doing with that one, we are reading emails, we are browsing web, and we are watching videos. And that was the ultimate computing machine 25 years ago when it was used such. So where we lose all that performance? The science has an answer. This article by Priest et al. From 2016 is an excellent one. That they found that kind of demand capacity services loop. So we observe and we anticipate increases or growth of demand that then drives the growth of infra capacity that then enables design of new services. For example, ChatGPT is 3 years old, and it could not have been done a few years earlier because there were no infra. And those new services, they provide us greater affordances, which stimulates demand. And here we are. And then that fancy little loop goes on and on until it sucks the world dry. It's further accelerated with the dominant paradigm in the IT services called cornucopian paradigm. Cornucopian means horn of plenty, runsauden sarvi in Finnish. That is based on user-centered design, technical and business drivers that drive the development, as discussed on the previous slide. There are two beliefs that both might be wrong in the future. They are sort of valid right now. One is the continuation of Moore's law. I don't know whether you know Moore's law, but there's one of the Intel engineers found out that the amount of transistors in the chip doubles every 18 months, and that has been valid until now, and it probably will continue to be valid for a while. So it means that every 18 months, the calculation, the computational capacity of the chip doubles. So if your software is slow now, then don't you worry, it will be blazing fast in 18 months or 36 months. There are some game studios that know that their game doesn't work well with the current phones. But it will be 4 years in development, so why optimize? There will be better phones. And then the infinite scalability of the cloud. Cloud is really, really ingenious marketing term. It sort of hides the fact that you're using somebody else's computer somewhere else, that emits the emissions, uses the energy somewhere else. It's somebody else's problem, not yours. The only person that has a problem with the cloud is typically the CFO of the company because he signs off the bills and considers why the heck we are spending so much money to Amazon or Microsoft. Both of these might be untrue in the future, and then everybody that has come to the industry after 2000, probably 90 something, when the Pentium was released, 95 or something like that, because then you had enough power that you didn't need to optimize all the time. You will be screwed because you don't know how to write tight code, but you have been using libraries on top of libraries on top of libraries on top of libraries. And a study made by Lappeenranta University of Technology says that people typically use 5% of the functionality of the library that they're using. That is using 5% of the library that it's using, and so forth, so forth, so forth, so forth. The design principles behind the dominant paradigm are that everything must be personal. Good example is that is there somebody that is still watching linear television in the audience, meaning the antenna television? Oh, there are a few. I didn't expect that, but there were a few. Good, because everybody else is using unicast, and those people are using multicast. So they are using services designed for groups, and you rest are using services that are designed for individuals. It's niftier to go to Netflix, except that I go to Netflix and then I check that what's available, and there's nothing interesting there. So in that sense, it's energy saving that I don't watch anything, but still, that is a good example. Variety, wide variety of services to be available. There are number of streaming services. The service must be available immediately. You can't wait a second or two. You get really frustrated why this thing doesn't work immediately. You want to create content that's shared with others. Everything must be of high quality. Service must be available from any device. And that's an interesting one, taking Netflix, that if you stop watching, that you pause something because somebody wants your attention, those little sneaky people around your house or something, they want your attention, and then you continue later in a bus. Is it acceptable to store, that the Netflix stores your location, sort of the where you stopped, every second, every frame, or even every 10 seconds? Because if it stores every frame, it's 250 times, makes 250 times request compared that it saves it every 10 seconds. But what do you prefer? That's a good question. Everything must be available at any time and in any location, so most of the stuff that we consume is consumed by mobile networks that are 10,000 times less energy efficient compared to the fiber optics. Everything must be eternal. How many of you deletes frequently photos in your phone? Oh, there are a few people. Excellent, because most of the stuff stays there forever, and then when it's backed up in cloud, every byte that you put in cloud is replicated on average 6 times. You probably have a lot of selfies that you have shared, and you have selfies that you haven't shared because you just took like 5 of those, and then you used 1, and you didn't delete the rest because it's cumbersome. And then users create content without regard to whether it's actually used again or not. And then everything must be rich, cross-modal and ubiquitous, so the service should interact together. And this sort of blows these things to the next level, because it amplifies effect of all those 9 before. And WordPress is not an exception to the rules of these. It actually drives a lot of those changes. So how to tackle the energy consumption? What can we do about it? 3 very simple rules. The less execution time is spent, the less energy is consumed when you are using the same environment. That if you have a single-threaded system that you make multi-threaded, and then it like you halve the execution time, then probably the energy is still consumed as usual. The less data you transfer, the less energy network uses. You need to understand that, for example, the optical fiber, when you turn the laser on, and it's always on, it consumes like 80 to 95 or 99% of the energy, notwithstanding whether you send data or not. But with mobile connections, it's a different thing. Then it typically uses energy only when you send data. And when you have less hardware in use, and this is problematic because nowadays in cloud you don't have any clue whatsoever at what kind of hardware there's in use, but there's less emissions caused. It might be that the hardware emissions can be like big portion depending on the devices. For example, this mobile phone. I don't know whose example this one, but thank you. When you buy a new mobile phone, 50% of the lifetime emissions have already happened. So hopefully that curbs you buying a new mobile phone, because your previous mobile phone is a decent device. There's funnily enough that when this few years back, that when Apple launched a new iPhone, then there were a lot of people that were sort of fumbling their previous iPhone to the toilet bowl in the US. That was in insurance statistics. There was a spike there because people wanted to have new phones, because we are made to believe that we are not whole unless we have the latest gadgets by marketing. So, as a web developer, web designer, you should shorten the user journeys. You should focus on the essential. You should reduce analytics to reduce computing. You should reduce page load, shorten pages, reduce errors, and limit videos to reduce bandwidth usage. You should design for older hardware, and for smaller screens, you should be nimble. You should not use the latest versions of the libraries unless there's a specific security issues, because they typically tend not to work on the older devices. Because why not? Why support old devices? It's cumbersome. It's bothersome. It's really hard. And we are really lazy in software development. Try to do less. Straight to the point, transaction done. There was one interview of a clerk in Dressman, and I like this idea that he said that there are people, men, that go to Dressman and buy 5 pairs of pants in a single time, that they don't have to come shopping every single decade. And I really like that one, that you get the money, you give the pants, and the person goes to the next adventure. So if you have a digital service that the user comes in, okay, press that button, input something, done, move forward. Really good. Don't bother him with all these kind of things. And then if you're working with marketing, try to figure out some other KPI, that how long the person has been visiting on your site, how many pages have been he or she has been seeing, because at the end, it's crucial that they see the page or the information that they're looking for. And do you know what is the most searched for sought for information on the website? It's the office address. And that's buried on the last page on the menu on the right-hand side, the lowest one, and the bottom of the page. And it should be on the front. If you want to visit us, come here. And then 90% probably of the requests are done. Okay, good, move forward. But there is typically a video of CEO saying that how wonderful the company is or whatnot, and then only he and his mother are interested about that video. So let's go to the measuring part. Firefox has an extensive profiler that is able to measure internal activities and then measure the power consumption. You activate it with fancy way that you go to profilerfirefox.com and then it pops up a new button in the toolbar. You need to have Windows 11 or Linux with Intel CPU or Mac OS X with Apple M series CPU. And last time we had trouble when we had a training with Linux, so your mileage might vary. But Windows, it works. I've seen it. With Mac, I'll show you how it works. This is what you're going to get. This is an eye test. I don't go through details, but it has plenty of information. So you need to configure the profiler. You go there, you edit settings, and then you turn the power as the default setting so that it measures the power consumption. And then you add a comma and a star to make sure that it measures all threads that are running. And this will change the profiler default to custom, and that's completely okay. Then you close the settings tab and you start measuring. This is not straightforward measurement. There's SiteSpeed IO actually does automate these measurements. But you open a blank blank tab, you clear cache if you need, if you want to do that. The caching does, because caching saves something like 10 to 40%, depending on the case of the energy consumption on the front end. Then you write the name of the page on the address bar, but you don't press enter, but you turn on the profiler and then you start profiling. Because if you write a long URL there or you copy it somewhere else, that consumes energy. The profiler will also measure. Then you interact with the page, you do whatever you want. Then you click profiler to stop the profiling, then you study results, and then something magic happens, and then you profit out of this process. The profiler provides you screenshots of during the profiling. It tells you what assets it did, what assets the browser loads, what was the bandwidth consumption, the memory usage, and the CPU, GPU utilization, energy consumption. And in Firefox, in Mac OS X, it provides per thread. In Windows, it provides is per CPU component. And then you can save the profiler, you can load it somewhere else. For example, if the profiler shows that there's a peak CPU usage of your site, then it might be worth to check out. That was the original purpose of the profiler, that you can actually figure out what's wrong with your site. There was an example of a site that consumed 100% of CPU and GPU energy that was mentioned by the profiler developer, and it was found out that it has a CSS file that changed the background color back and forth, faded in and out, and then everything was red on the computer. So in Mac, you get to see strips for each process, and in Windows, you get to see these CPU core, CPU package, and iGPU. Depends a bit of the processor what you have. The measurement happens inside the CPU, and there's the OS providers provide the interfaces that this one uses. So this is as precise as it can get right now. Intel, it measures all the other things. So if your Windows is updating while you measure, then you will get really weird results. So kill all the other softwares. Don't do anything else but Firefox. In Apple M processors, it's only Firefox processes. So then it means that, for example, the OS window manager and the OS network stack is not measured, and they might have some consequences. If you have active plugins, they might actually. We fell to that pitfall. Everything is dutifully recorded by the profiler. If you start with non-blank page, then it will measure the energy consumption of that content what's available on your page. Scrolling consumes energy, and then if you don't execute scrolling properly every single time the same way, the results might be non-comparable. The profile uses best unit. It might be milliwatt hours or microwatt hours, and there's 1,000-fold difference, so check them carefully. This is Physics 101, but still, that mistake has been every single time when I've been helping people to use that system. Somebody has made that mistake. You can install a plugin like Clear Cache to clear the cache. It's more cumbersome to do with the menus and so forth. You need to remember to clear the cache with blank page, because otherwise everything that's on that page is still in the cache, or gets back to the cache when it downloads something. And then if you want to do constant scrolling, then you can use Fox Scroller. You can use SiteSpeed.io. You need to configure it to use Firefox, measure energy consumption, and use all threads. And then you have the accept or decline cookies. The cookies declining cookies saves around 30% of energy on the front end. So decline every single time that you can. There's a GitHub, me and Juho Wepseläinen, we made a scientific article that is currently in peer review about this. So that is the page where we have our site speed configuration. The funny thing is that if you leave the site on, it will consume more and more energy while time go by, because it most of the sites ping back all the time that where you are, who you are, what you have been doing, and so forth. There's loads of JavaScript running that will continue to run. So the longer you are there, the more energy is consumed. So that's also a good way that just stop browsing. I don't know whether that is sort of something that you could actually do, but close the lid of the computer, go out, enjoy the autumn right now, and so forth. So we have a big differences, and then if you think that these are really small numbers, the Mac is like 50 times more energy efficient compared to Windows. So that's good, and this doesn't take into account the displays and so forth. But it still gives you understanding that whether you're doing good or not. If your commercial sites go below 5 milliwatt hours, I made the same mistake, 5 milliwatt hours when scrolled halfway down, that was the 53% is the where the people typically scroll the sites. That is also scientifically checked. Non-cached with cookies on, that is the usual situation, then you are good with M3 Pro. If you have M1, then it consumes less energy. M4, it consumes more energy. If you have in Windows, it's completely different. So the horizon is still something that is unclear. We have a horizon for M3 because we made measurements with 100 sites, and that's around 5 milliwatt hours. And for the non-commercial sites, it's 1.5 or something like that, the government sites. So they are typically leaner. Energy saving is a journey. If you now felt the sting in your heart, and you should, if you haven't already, that you should do something about it, then don't expect the changes that they can be done at once. That is not the case. You need to keep the client, internal or external, there's always a client, needs in primary focus and agreed within the budgets, because happy clients are way more interested in making changes. If you come to say to the client that, dear Mrs. Client, I have these 5 ideas that I would like to implement to increase the energy efficiency, and she said that, okay, maybe implement 2. Always come with bigger number that you are aiming at, because there will be always cut down. But if you have an unhappy client, and you go there, dear Mr. Client, I would like to implement these changes, these 5 changes, and he takes a list of his own. Yeah, that's fine, but I have these 200 changes that you need to do first, and for free, preferably. Don't set up too ambitious goals, and do not try to gobble everything up at once, because you will choke, you will burn out, and you will be replaced by an idiot that doesn't care about energy consumption. But in all journeys, the most important thing in starting a journey is to take the first step. And I have really, really good news for you, because you have been listening to me. You have everybody have already taken the first step. You are already on the journey to reduce the energy consumption. And I just ask you to keep on walking. Thank you.
Thank you very much, Janne. Very interesting topic. I'm going to come up here, and we have a bunch of questions from the audience. First question. I contacted around 25 experts on LinkedIn yesterday using Chrome, Linux version. After about 20 messages, the browser froze and used 2.5 gigabytes of memory. How common is this?
Typical behavior, I would say. If you go to Chrome, shows the how much memory is used by every tab, and I have never seen a tab using less than like 100 megs. So it's weird that where it goes. The funny thing is that if you think of the Helsingin Sanomat or New York Times or any other newspaper, the amount of content that you read is probably like 5 kilobytes, 5,000 characters, give or take. And the websites that delivered them 20 years ago, they were not like 5 megs or 10 megs or 15 megs that they are nowadays. So where it's going, none of that change benefits you as a person, but it benefits the people that sell you as the product to the advertisers.
Thanks. How do energy saving in front end in general and in front end in general compare to with AI usage? For example, if I use ChatGTP or Gemini to help me save energy on my website, have I lost all savings with prompting?
That's an excellent question. I always say excellent question when I don't really know the answer. The latest paper from Google about the Gemini AI, if I'm not mistaken, and that's why I'm a bit hesitating, it was that the one prompt, was it 0.25 watt hours. So it's 100 times or 50 times more than or 50, yeah, you could open Hesare for 50 times and then it's done. So in a principle, if you could reduce with the big site that has a lot of users, then using a few prompts doesn't really matter. But if you wipe code the whole stuff, then it's interesting. There was a discussion in one training that they calculated that if you make like 100 prompts a day, that is the amount of the coder typically does, it will be the use of AI is using the same amount of energy that your laptop. So it doubles the energy consumption of your laptop, taking that we're using Macs that take like 20 watts in approximately. So in that sense, it's not that big. But then the differences in prompting has a number of course, and then if you use ChatGPT as your only friend, for example, that is the major use case. One of the two big ones. The two big ones are that there are mental health and using AI as a friend. And I'm a bit concerned that if you have a friend that is always agrees with you every single time, is that good for you or not? Really good question. So if you use AI to save energy, then it's typically completely okay, unless the site is something that you and your mother only use. Then it might be that it doesn't really matter. It's about the impact of the end result at the end.
All right. Someone asked here, are there any tools to estimate server side or cloud service energy consumption, like if marketing would like to implement the latest AI gadgets and their impact is not visible on profiler measurements?
Oh, there's not.
Right.
Except that there's, was it Gerd-Dietrich Hoffmann? I'm not sure about the first name, but the Hoffmann should be the last name, has made Linux kernel extension that provides profiling information of all the processes running in Linux real time with less than 5% overhead. So you could do it. There's no way in hell that you could do that in cloud, and most probably never will. But you can run with your own hardware and you can try to simulate the cloud. But if you WordPress in that sense is good that you can run it on your own system. But if you are using heavily cloud services, then you're probably screwed that you don't have any possibility to move the cloud services to your host because you don't know what they have eaten. The good thing in a sense is that probably the biggest cost for the cloud provider is the data centers, the hardware, and the electricity. And if you can optimize things, then you cut your cost while you keep the price of the SaaS services or PaaS services, IaaS services still up. So they have incentives to do it. Whether they want to do it, it's a good question. Now they are buying nuclear power in states, for example, and then they are using gas if nuclear is not available because every other thing is either unreliable like wind and sun, or not available for the renewables. The electricity that US data centers use is on average dirtier than the US electricity in general, which is really screwed up situation. They claim to be something else, but they are not.
Mm-hmm. How about this? So if websites consume energy constantly, should I keep my tabs open in Chrome or as such or in groups, or should I just close them when not used? What do you think?
I would use the Chromes and probably Firefox as same, that it will stop the inactive tabs quite frequently. The human nature is that everybody has tabs, so I would rely on the browser to manage those more than I would do myself. Of course, if there are certain sites that consume a lot of power, then I would close those if you know that which they are. But then probably it's also that the usability of the browser might, like with the case with LinkedIn, might actually suffer, and then you know that maybe I should get rid of this one. The other big thingy is those Electron-based applications like Slack and the others, because they have both Node.js and Chrome installed inside, and they have several that you probably have several instances running of those systems. The best ones are those that are in the Mac menu bar. There's one icon on the menu bar here, and then you have Node.js and Chrome running because of that icon. But let's not go there. I have number of rabbit holes that I could go, and there's no Wonderland on the other side, but that kind of sinking feeling that I should dig a hole in my summer house and live there, because that would be the best way to handle those situations. So don't think too far, because you might get lost with your thoughts, and then you might lost your meaning as a developer and so forth. And it's better that you are concerned about these things, that you are not using the systems at all.
Great. A lot of good questions. Just a few more. And I'm not really sure if I understand it, but maybe you understand the question, but should there be industry-related benchmarks for the front-end energy consumption?
Yes.
Yeah. Okay.
And we are making those. We calculated the consumption of 100 big sites in US, Finland, Sweden, Germany, and UK. That is now pending in the peer-reviewed paper. I can't really go to details, but we found out that there's certain horizon for different industries. We checked news, sports, e-commerce, and government, and the government was really smaller than everybody else. Especially the German government was really efficient. UK government was really efficient. Swedes were not. Finns won this time. So if you are Finn, you understand how big thing this is. And then the Americans sort of showed not caring also on the government side, as they do also in the commercial side. If they are Americans now, you can beat me up later.
Great. One final question: is it possible to get this presentation?
Oh, yes. I'll provide it somewhere. Probably if you follow me in LinkedIn, then that's probably the easiest way. There are two Janne Kalliolas. Don't take the other one with me, the original one.
The OG.
I'll provide it there.
Great. Thank you very much, Janne Kalliola.